Today is September 9, 2021. This is a Thursday lab. First experimental measurement, okay? So, step by step here. Word. P37Lab notes. No, desktop. P37 lab notes. You go. 090921. What you gotta do? Download. First thing. Download P37 Tuesday L01 group X from the shareable folder of my Google Drive. Okay, 2. Rename P37 Tuesday as P37TH. Don't do anything different. I need everything in the proper format so I can organize properly my hard drive there at home. And put your group number and replace X with your group number. Okay. Open the document. 4. Let me get that. Here you go. I'm going to rename it as Thursday. In my case, it's going to be group 0, right? Because I don't have a group. Here you go. I'm renaming it. Open the document. Next step. Open the document. Here you go. Write your group number, name of students 1, 2, 3, and put the date of the experiment. Okay. On the left corner of the spreadsheet, write your group number, the student, the name of the student, and today's date. Okay, so here you go. And here we have a table. Identify what is measurement and what is result. Identify what is measurement, what is raw data, and what is results in the second table. Okay, that's the most important table of today's experiment. Okay, there are more, but that's the most important table one. This table here. We are going to I'm going to distribute 6 different spheres to you. All those spheres have different diameters. You're going to measure the diameter of the spheres with the ruler, with the vernier caliper that looks like that, and with the micrometer that looks like that. Okay? 3 different diameters. But you are also, those are all raw data. They're all raw data here. And you're also going to measure the masses of those spheres using the scale is there in the cart. When you enter the data for the diameters, my Excel spreadsheet will automatically calculate the volume of the spheres, and the equation is already here. You don't have to type anything. You don't have to calculate anything. Automatically, here you go. I'm going to put 1 meter here. Look at the volume of the sphere. Okay? Calculate automatically for you. But you got to put the right number of sequence figures too. I didn't, you got to put the right format. Right now, the format is not the correct one. You have to adjust the format so you have the right number of sequence figures, okay? The units, you got to fill up the units here. There are units only here and here. But then you got to fill up the units that are in blank. Okay? That's the main table. Right in here, you're going to go in the book, in the internet, and you look for the density of steel. Whatever is written there in the internet, you type it here. Most likely you're going to get a range of values because the steel has, depending on the type of steel that you use, it's going to have a minimum and maximum value. So you just, write down the average value of the steel there in the spreadsheet. Here there is no need for significant figures, okay? Here you go. Whatever is in red, you don't need to worry about significant figures. But everything else that's in black, you worry about significant figures. There is no need for significant figures here. No need for significant figures here. Okay? Being recorded right now. And is that clear? Okay. So what I'm going to do right now, I'm going to distribute the equipment. So there are, we will use the following material / equipment. Don't forget, always bring your remember, one laptop per group, okay? Because today is the first experiment, we're going to continue this experiment next week, and there will be no lab report due next week, okay? So we're going to collect the data, and then next week I'm going to show you how to work with that data. So we'll use the following material. 1, a ruler. 2, vernier caliper. 3, micrometer. 4, scale. 6 spheres of different diameters. What else? You need a laptop, right? Don't forget that. What else? That's it, right? Yeah, that's what we need for today's experiment. So you will measure the diameter. You will measure the diameters of 6 different spheres. And what I want to do, I will start distributing the ruler and the vernier caliper, and then later on, don't forget the scale too, right? Later on, I'll give you the micrometer. The micrometer is a special tool. I don't want you to touch it yet. But let's start. Group number 1. Come by, group number 1. Go. And I'll go ahead and get your scale. Group number 2. Get your scale too. Group number 3. Get the scale. Just the scale, nothing else. Group number 4. Get your scale. Group number 5. Get a scale. Group number 6. And group number 7. Okay. Get the scale. Good. Now. I'm gonna do that. I'm gonna sort out your spheres. I'm gonna distribute the spheres. Okay. This. That. Oh gosh. Oh. Let's see here. There's a better way of sorting this thing out. Nope. Okay, so here we go. Face. Okay, group number 1. Come by, pick up your spheres. Number 1 is gonna get 6 spheres. Make sure there are different diameters. This looks like they are 1, 2, 3, 4, 5, 6. Here you go. Don't lose them. Okay, oh, one more. Group number 1. 6 spheres. 1, 2. Okay, don't forget. I need you to return those spheres to me. Okay? I'm keeping track how many spheres each group has. 1, 2, 3, 4. Cinco, one more. Okay, group number. Let's start group number 2. I'm gonna give you 5 spheres, and then you try to group number 2. I don't have enough spheres for everybody, so you have to share among the other groups, okay?
It's 25?
5, only 5, but you gotta get the other one from another group, okay? Group number 2. 5. Don't forget to return those spheres to me. 5 spheres. Let's see. 1, 2, 3. Quatro. Okay, group number 3. I'm going to give you 4 spheres, and then you look for 2 other ones with other groups that have different diameters, okay?
Okay.
1. Your group number 3, right? No, let's see, next. Your group number 4?
Yeah.
Let me collect that all spheres for you. You should keep those things separate from scratch, so you don't. Okay, I'm gonna give you 4 for now. You're gonna need 2 more. You're gonna share with the other
Different sizes too, right?
different sizes. Yeah, they all have to be different sizes.
I'm talking about the other two that we are
Yeah,
collecting. So
has
they
to
should be different sizes.
different sizes.
Thank you.
4 spheres. Let's see. Group 5. What? Looks like I have only 4 spheres here for you. Okay, so you are gonna need to get 2 more spheres shared, with another group in the classroom. Okay. Group number 1 is the one that has all the 6 diameters. There you go.
And they're all different?
Yeah, they're all different. And you're gonna get 2 more that has different diameters.
Okay.
Group number 6. Let's see. Let's see. 1, 2. Looks like I have only 2. Oh, I have 3. Okay. Yeah. So you're gonna need 3 more. You're gonna share,
Just go find some more.
yeah, with the other group.
Sorry.
Okay, that's okay. 3, right? 3. Your group number 6. 6, right? And group number 7. Come by, pick up your spheres. Let's see how many I have. 1, 2, 3. Looks like I have only 3. You're gonna need to get 3 more from other groups, okay? And they have to be, you're gonna be sharing. They have to be different diameters. There you go. 3 spheres. Don't forget, you have to return the same number of spheres to me at the end of the class. Paragraph. Yeah. Yeah.
How do we read the
Yeah, I'm gonna tell
page
you.
back?
Yeah. So hang in there. We start with the ruler first, okay, and then you worry about the vernier caliper, and you can measure the mass stuff too, right? Start by measuring the diameter with the ruler and the masses of the sphere. Okay, and label them 1, 2, 3. They don't have to be, larger to small. They don't have to be. Can be whatever order you want.
Professor, for the it measures in millimeters, right? But do you want it as like the
Oh,
standard
you
unit
have
is
to convert.
meters?
Yeah, you have to convert. You have to convert, right? You have to convert the measurements, whether it's from centimeters to meter or millimeters to meter. Okay. Measure measurements. One. Measure the diameters with the ruler first. Then measure the masses of the sphere with your scale. I will brief you how to I'll brief you how to use the vernier caliper soon, okay? Let me get some. Oh, yeah. You want need the tape to tape the sphere to the surface of the scale, okay? Tape to ensure the spheres.
Giant.
I'll brief you. Yeah, I'll show you. It's the micrometer. This is a micrometer
Oh, okay,
for
okay.
educational purposes only.
So we do that last.
Yeah, we'll do that last. Uh-huh.
Here we go.
You need the tape. The scale.
It's like
Okay.
I have a question.
Yeah,
What does this read?
I'll get to you. I'll get to that.
Okay.
Hang in there. Just I will brief you all very soon on that. Okay, so are you done with the ruler measurements? Nope. Are you done with your measurement? So I want you to make measurements with this scale and with the ruler.
Professor, our
Yeah.
scale is it's not balanced.
Yeah, there's a reason, right? Put it here. Put it here. Yeah, here you go. Let's see, this one too. See that? This one here? This one? Okay.
Oh wait, oh.
Okay, but then you gotta okay, and then you gotta nail
Yeah.
this guy here. Oh, here you go. This knob. Okay.
Oh,
Move it back
okay.
and forth until the needle is
That. Oh,
centered.
okay.
Yeah?
Thank you.
Yeah.
Do you want the scientific notation like this? Because when I typed in 8.54 and it just came out as 9.
Yeah, you gotta change the format.
Oh, okay.
I have changed the format, okay? Let me write that down here. You go. Okay, do log your measurements in the spreadsheet. Do not forget to use the proper format for the cell, right? Using, by right clicking in the cell and selecting format cell. Here you go. Try that. Okay. The correct significant figures are A. For the ruler, there's gonna be x dot x centimeter, which is equal to, let's say, 0.0xx meters. For the vernier caliper, x.xx centimeter, which is equal to 0.0xx meters. For the micrometer, So how are you doing there? Let me know whenever you're ready to use the vernier caliper, okay? Okay, I gotta wait for the others. So hang in there. Which group are you? Which? 7? Group 1. Ready? Yes. Vernier caliper. Ah. Okay. Group 1. Group 1. Which group 1? Are you ready for the vernier caliper? Not yet? Okay. Group 2. Are you ready to use the vernier caliper? Almost? Okay. Group 3. Who is group 3? Are you ready to use the vernier caliper? Yes? Oops. Group 4. Are you ready? Okay. Group 5. Who is group 5? Who is group 5? Are you group 5? Are you ready to use the vernier caliper? Yeah. Group 6. Who is group 6? Not yet? Okay. 3 more groups to go. Next time, next time to make things easier for me, let's do the following. Let's get group 1 here, right? Group 2 there. 3, 4, 5, 6. No, let's see. I want, 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. Let's do that next time. Okay. Yeah. Yeah. Right now, as you can see, is that how many digits you must have there. Okay, so you count the decimal place, so it has to be pretty much 202 decimal places. See how many digits you can get there. 203 decimal place.
Every measurement is different. We pick decimal place with 1,000.
Well, it's the what we have, you know.
Because yeah, the first one.
The best way write it down here. Right here. That's the best place to okay? And it's easier to format that to the spreadsheet. Don't try to go straight to the spreadsheet. Is this okay now?
Yeah.
Well, how many student figures are you supposed to have? Do you have two student figures there? It was what, 1.2 centimeters? Now it's better to put in numeric format. Okay, don't use it in scientific format. Scientific format you use only for numbers less than 10 to the minus 3 and greater than 1,000. Here you go. I'm gonna write that down here as a good rule of thumb. As a good rule of thumb, use scientific notation for values less than 0.001, less or equal, right? Less or equal than 0.001 and greater or equal than 1,000. That's a very good rule of thumb. Every Okay, so let's see. Okay, group one. Are you ready for to use the vernier caliper, group one? Not yet? Okay. Group two? Yes, you're ready? Okay. Group six. Are you ready to use group six? Who is group six? Are you group six? Are you ready to use vernier caliper? Yes? Okay, only three?
Only three for right
Yeah,
now, yeah.
look around who has the other three diameters. The other different diameters. What? Yeah, you can do the other three later on. Yeah. Okay, so you're ready, right? Okay, so let's work with the vernier caliper now. May I have your attention? You know, it's not easy when you're working for the first time. It's not going to be easy to work with vernier caliper, okay? Unless you have a digital vernier caliper. We don't have digital vernier calipers. Digital vernier calipers is just displayed to you in the screen what's the measurement. But those ones who are not digital, you know, you have to learn how to use it. What's the advantage of the regular one from the digitals? You know, I have a digital vernier caliper there at home. They don't last very long. They break down easily. those, those ones that you have in there, they last almost forever. Okay, I have a vernier caliper there at home that I bought with a project of mine. I bought it in 2003 and it's still working. A mechanical one. A digital one that I bought like 4 years ago, it's no longer working. Okay, so 2003, you do the math, right? Almost 20 years, and it's still in very good shape, pretty good shape. So let's see how we use vernier calipers, right? I have here a PowerPoint. That's how, that's a very simple illustration of a vernier caliper. That's not exactly how it looks like, but it looks like somewhat like that, okay? Here you go. You have, go ahead, open your vernier caliper, okay? Just like that. So the vernier caliper has this main scale that's just your regular ruler, right? And then it has this smaller scale right in here. This is smaller scale. Take a look there. I illustrated in my PowerPoint just like that. It's this scale is a special scale. It's called the vernier scale. This type of scale was invented, something like that was invented back in the 1400s, 1500s by the Portuguese navigator that I told you, right? Did I tell you about the Portuguese navigator? Portugal was the superpower of the time. Portugal was founded in 1300, and it was the first European country that managed to unify itself politically. And because they unified themselves politically, they were able to start navigating the whole world. Portugal settled colonies in Africa. They were the first Europeans to get in touch with the Japanese. Who has Japanese background here? Japanese? Who is Japanese here? Nobody has a Japanese background here? No? The Portuguese were the first Europeans to get in contact with the Japanese. Have you heard of the city of Nagasaki? Huh? Have you heard of the city of Hiroshima? Yeah, right. Guess who founded Nagasaki? Guess who founded Nagasaki? It was not the Japanese who founded Nagasaki. It was the Portuguese who founded Nagasaki. Those stories, they don't tell us there in Brazil, because we were settled by the Portuguese, right? They don't tell us that to us. We end up learning later on in life. And the story goes that the Japanese, they didn't want the Christians, they didn't want Christians in their country, and they were repressing the Christians there in Nagasaki because it was founded by the Portuguese. The Portuguese were Christians, right? And spent like hundreds of years, and the Japanese couldn't end up with the Christian religion in Nagasaki. Hundreds of years. It took hundreds of years. They couldn't do anything. And it took just one atomic bomb to decimate the whole city, right? So what was it? And it was a Christian country that destroyed a Christian city in Japan. Okay? So that's what they tell there in Japan. So that's the path of the Portuguese. And there was this navigator, this mathematician, inventor, and navigator called Nunes, that invented what would become later on the vernier scale, what you see right in here. Okay? He discovered a way to make a ruler, to increase the resolution of a ruler. That's what he not discovered. He invented a way to make a ruler have a higher resolution. And the nice thing is that there was a very important astronomer of the time that used his invention in his own instruments. His name was Tycho Brahe. We're going to talk about Tycho Brahe later on. Okay? And later on, this French guy called Vernier looked at the invention of the Portuguese guy, improved on it, made it easier, and renamed the invention the Vernier caliper, the Vernier scale. What was the nonium, right? Nonium coming from the name of Nunes, the Portuguese navigator, became the Vernier scale. Okay, so how does it work? You gotta understand how this thing works. Take a look, Go ahead and now you have two scales, right? Regular scale and the Vernier scale. Those two scales working together allows you to make a better measurement. Okay? So I want you to close the scale. Let me see if I can do that. I'm gonna get it out of here. I'm gonna close the scale here for you. Oops. I'm gonna close the scale on my own. Here we go. And I want the 0 of the vernier scale to coincide with the 0 of the main scale. Okay? You know, count how many divisions we have here in the vernier scale. 10, right? And the next thing, what is the length of the vernier scale? Of those 10 divisions of the vernier scale. Take a look. Take a picture with your cell phone, you know. Count how many, I already have here for you, you know. Say, from here to here, how many millimeters you have from here to here? 10? You have 10 divisions. But what's the length from here to here? See? 1, 2, 3, 4, 5. Check it. Check it out. Huh? Yeah, take a picture and yeah. So 10 divisions in the vernier scale is equal to how many millimeters? 9. Okay. So 1 division in the vernier scale is equal to how many millimeters? Huh? 0.9, right? Just by using this special type of scale, we are capable of increasing the resolution of the instrument. Okay? So if here is 1 millimeter, if here is 1 millimeter, here is 9/10 of a millimeter. Just by manufacturing a scale that works like that, you are capable of increasing the resolution of your instrument. Okay? We use this type of scales not just in a linear instrument, but also in an instrument that rotates too. Okay? We have instruments that use the vernier scale in this way. So now in the next step, what I want you to do, go ahead, get a piece of tape and cover your scale. But leave the 0 of the vernier scale uncovered. I want you to just cover from the first to the last division in the vernier scale. And only in the vernier scale, okay? Do not let the thing move upwards. I want the 0 here to be uncovered. Do you get the idea? Go ahead and get a piece of tape. If you need a scissor, I can get a scissor for you. Do you need a scissor? Yeah, let me get a scissor. You can do a nice job covering the scale. Here. Ideally, we should be using a blade for that, but we don't have a blade here. We have a scissor only. Come by and pick it up, one per group, so you can cut nicely your tape. Wow, we did a good job. And once you do that, you're going to play with the vernier caliper. You're going to measure the diameter of the spheres with the vernier caliper without the vernier scale, okay? Because you're covering most of the scale. Okay? There's a very common mistake that students make with this scale. with this instrument. It's a very common mistake. When the students make measurement with this instrument, you know, what the one important mistake that they made, instead of looking at this zero lined up with the upper one, what they do, they look at this edge here of the vernier scale. It's a very common mistake that students make, okay? I have seen this mistake over and over again. Don't look at this edge. Don't look at this edge, okay? So the common mistake that students make, that they look at this edge here of the vernier caliper, right? Instead of looking at the zero of the vernier scale. Make sense? You gotta remember, when you close it completely, the zero of the vernier scale must coincide with the zero of the main scale. Okay? Here you go, just like that, right? So that's your reference, not this one. This one is not your reference. Your reference is this one right in here. Mm-hmm. Wait a minute, 10.2 millimeters. Yeah, it's not 10. No, right now it's not. But the diameter of the sphere is 10. Okay. So does he get the answer in millimeters? Wait a minute. Not 10.2. Yes. Remember, you're covering the vernier scale, okay? So you're using your vernier caliper, though it is a ruler. It's not 10.2. It's not 10.2. Take a picture of your cell phone. It's always good to keep a record of those things. It's the same principle. So here you go. Okay, here you go. I'm gonna help you out here, right? Here you go. What is this measurement here that I have right now? This vernier caliper is indicating what measurement?
Zero.
Zero, okay? Now I'm going to increase a little bit. Okay, now what about now? What's the measurement that I have? 5? 4, right? 4, right? Exactly 4. Now, what about now? 11? Look better. 12. That's the measurement that you have in there. Okay? That's the measurement that you have in there. You have 10 millimeters, 11 millimeters, 12 millimeters. Okay?
So should we give the answer in millimeters or centimeters?
Well, all your answers must be in meters. Whatever way you measure, you convert it to meters. Okay? Whatever way you measure. Everybody's familiar now? Remember, first step, learn how to use the vernier caliper without the vernier scale. That's the first step. That's what we're doing here. Okay? Learn how to use the vernier caliper without the vernier scale. That's what we're doing right now. Make as many measurements as you can, okay? Put it aside, don't log it in the spreadsheet yet. And then I'll show you how to use the vernier scale. enough fratzy with the vernier caliper. And compare your measurements of the vernier caliper with the ruler, right? Compare the above measurements with the measurements made with the ruler. And see if they match. They should be very close to one another. See if they match. Okay, whenever you're done, let me know so you can move forward. Okay, so are you ready? Now let's take out the tape from the from your vernier scale. Are you ready? Remove tape from the vernier scale. And now we are going to do an actual measurement, the vernier caliper. Okay, does anybody has ever used the vernier caliper before? Who has used it? Never? Never? Okay. Anybody else? Have you? Electronics, okay. Okay. Mhm. Okay, so let's go. Let's another exercise here so you can understand how the vernier caliper works. Okay, here you go. close your vernier caliper. Close your vernier caliper. Okay? And now you do the fold. The 0 here is lining up with the 0 there at the top, right? So now I want you to do the following. Open just slightly. So the very first line here coincides with the line at the top, okay? Here you go. I'm gonna do like that. Here you go. Now this 0 here is a little bit displaced, right? But the first line here of the vernier scale is coincide with the line above. This measurement is no longer 0. This measurement is what? This measurement is 1/10 of a millimeter. Make sense?
Yes.
That's 1/10 of a millimeter, this measurement. If you move a little bit more, so now the second line of the scale coincides with the one at the top, now this measurement is going to be what? It's going to be 2/10 of a millimeter. Make sense? And so on. Okay, here you go. That's going to be that's going to be 3/10 of a millimeter now. That's going to be 4/10 of a millimeter, and so on. Okay, you have to look at which one of those lines coincides with the one at the top. The measurement is going to be 0.5 millimeters. Okay, we are using the vernier scale in conjunction with the main scale. So if you have a measurement, a generic measurement like that, so here you go. I'm going to make it very, exact. What you have here is 16 millimeters, 0.0. The 0 here of the scale coincides with the line there at the top. So what you write that down? You write 16.0 millimeters or 1.60 centimeters. Okay? If it's just a little bit off, let's say this one here is going to be 16 millimeters plus something else. I can zoom in here for you. Here you go. 16 millimeters plus something else. This something else, is going to you find out by counting determining which one of these lines line up with the other one at the top. 1, 2, 3. So you write down 16.3 millimeters. Okay? And so on. Okay, this one should be 16.5. Okay? And so on. And vernier scale was not drawn properly, okay? But gives you an idea how to use it.
Professor, are we using the micrometer today?
Yeah, we're using today. So go ahead, make all your measurements. Now you should know how to make measurements with the vernier caliper, right? Whenever you're done with the vernier caliper, let me know, and then we start with the micrometer. And as you go along, make sure you take pictures of your measurement with your cell phone. Make sure you take pictures of the measurements with your cell phone, okay? It's easier to read a picture in the cell phone than to read the actual measurement in the device. What time is that? 8:32. Scale. Okay. Okay, how are you doing there? Are you ready for the micrometer? Yes? Okay, so if you're ready for the micrometer, I need you to pay special attention to what I'm going to tell you right now. May I have your attention, please? Always. See, you have a knob right here in the micrometer, right? This knob has a reason to be there. Always handle the micrometer from this knob, always. Never from here. There's a reason for that. And the reason is you can damage the instrument if you close the micrometer using this knob here. Do you hear something clicking? Okay? So what we have here, we have a mechanism to ensure that you're not going to damage the thread of the micrometer. Okay? If you close the micrometer using this knob, you are going to damage the thread of the micrometer and you have to throw it away. Okay, if I see anybody handling the micrometer from this knob, I'm going to take 10 points from the whole group, okay? I'll put here my notes. So always open the micrometer from this knob, close the micrometer with this knob, okay? So come by, group number 1. Pick up your micrometer, here you go. I'll walk you through how to work with the micrometer. This one's not good. Group number 2.
Thank you.
Group number 3. Good. Group number 4. Group number 5. Group number 6. Group number 7. Here you go. Okay, so let's learn how to work with the micrometer now. There is a very nice simulation in the internet about the micrometer, how to work with the micrometer. Micrometer. simulator. Okay, this is a Brazilian website. Okay, 1,000 inch, hundreds of millimeter. Okay, 0.01 millimeters. Go, if you have the opportunity to go there, it's a good simulation. Here you go. Here's the resolution of your micrometer. See that? 0.01 millimeters. Okay, so here you go. The first thing I want you to do is to open the micrometer completely. Here you go. That's the first thing I want you to do. Don't forget, handle from the knob right in here. Okay? Go ahead, open it. And you're going to see again the micrometer and the vernier caliper, they're just like rulers, right? See the main scale right in here? From 0 to 25 millimeters. Both the micrometer and the vernier caliper has the main scale that is just like a ruler. Let me close the eye here. So we have the top scale that's in millimeter, 0, 1, 2, 3, and so on, right? And then what do we have at the bottom? What do we have at the bottom? You have the half millimeter scale. 0, half, 1, 1.5, 2, 2.5. Okay? Have you ever seen a ruler like that? With half millimeter scale? I have seen. Yeah. Yeah, they sell it out there. Okay. It's not easy to find, but I have seen that before. Rulers that had half of a millimeter division here. Okay, they do have it. They exist. So, and then so we have one scale, we have a second scale, and then we have what? A third scale, right? Okay, and if you want, you can put a vernier scale here in this micrometer too. This micrometer doesn't have a vernier scale. The one that I have there at home has a vernier scale. The one that I bought there at home has a vernier scale in them. Okay? So if you put a vernier scale in this guy, you're gonna go to a thousandth of a millimeter. You're going to go to a resolution of 1 micron. Okay? Have you thought about that? That's how useful the vernier scale is the vernier scale is. Now let's close. Remember, close the micrometer. Knob. And now when I completely close, see this 0 here? Go there. The outer knob. Are you getting there? I'm gonna close this one too. Here you go. If your micrometer is calibrated properly, this 0 here in the rotating scale is going to coincide with the horizontal line. Sometimes the micrometer is not calibrated and there will be a small difference. So check if it's properly calibrated or not. If it's not, then your final measurement will have to, you have to subtract or subtract or add a small difference that you're seeing there. Let's see this one here. Here you go, close completely. Let's see if this one is calibrated. This one is not calibrated, see that? the 45, you know, the 0 is below this line, right? So you're gonna have like 6 divisions of difference. 6 divisions. Oh, yeah. Every time that you make a measurement with this, with this micrometer, you are going. Oh no, it's not 6. It's more. Oh, it's more. Wow. It's 11. 5, 10. Oh, almost 12. For this micrometer here, every time that you make a measurement, you have to add 12 divisions to your measurement. How does it look like in yours?
It's off by one. It's off by one.
Off by one?
But what is that third scale? What units are those?
Oh, we're gonna get there. We're gonna get there. You're gonna find that out right now. So just put, but it's off by one. What does it mean off by one? Is like one above or one below? It's like that?
Below.
Huh? Below?
Below
Okay.
for us.
So if it is one below, it means that you have to add. Oh boy. Ah. It means that you have to add.
Add one.
Yeah. And you're gonna understand what how much each division is. Okay. So got it. Now let's do one more exercise here. Several exercises so you can understand how the instrument works. Okay? The next exercise you're going to do, you're going to go a full revolution of this scale. And by the way, take a look here. This scale goes from 0 to 45, right? Is that 45 really? Is what? Ah, it's 50, right? 45, 46, 47, 48, 49, 50. See that? It's 50 divisions, not 100 divisions, okay? And there's a reason for that. You're going to see, go one full revolution of this scale. You want the 0 to go back to the initial point. And then you're going to understand what's going to happen. One full revolution. Right in here. Let's see here. Oh, yeah. Do you see this little line showing up right in here? Yeah. What does it mean?
It's half.
Past?
Half.
What do you say?
Half.
Half. Half what?
Millimeter.
Yeah, half millimeter. You go one full revolution with the micrometer, you open up half of a millimeter. Here. Make sense? 50 divisions is half millimeters. 50 division is half millimeter. One division is what? Do the math. One division is one what? One what? 1 millimeter? 100. Let's do. Yeah, here you go. Yeah, I heard you. 50 divisions is half millimeter. One division is X, right? Half millimeter divided by 50. Right? So you can even multiply by 2. You get 1 millimeter divided by 100, right? 100? Yeah, 100. So what's that? One division is equal to what? One division is the resolution of your device. Make sense? That's what it means. So, let's go to the next step now. Are you getting the idea here how this thing works? Okay? Now you can do, let's make a measurement. Let's make this measurement here. I'm going to get a simple measurement here for you. And let me see if I can get it. And then you tell me. Okay? Can you tell me what is this measurement? Count 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're about to see this other one, right? 10. Yeah. 10.0, right? 0 millimeters. 10.00 millimeters. Okay? Now let's do another one, a little bit more difficult. This thing doesn't move. Okay, here you go. Okay. What about this one? This one is a little bit more difficult. Write that down. We have 5, 10, 15, 19. See that? 19 right in here. 16, 17, 18, 19. See if you get it right. 19 point what? Someone said 9.4? Okay, anybody else? 9.4? Why 9.4? Because we are past the 19.5, right? Some students don't notice that. See, it's 19, 19.5 plus 0.44. Okay? So it's 19.94. You can even see it here. You go. Oh, 93. Why did you say 93? Oh, because he has 7 tenths here. Okay. Yeah. In this case, okay. Uh, yeah, there's a reason why he showed that in there. Let me see if I can get it. It's a matter of getting the right resolution. Okay, now we got it right. Now we get 19.94. Okay? Okay, this micrometer works in the same way that yours work. Okay? Can you do the measurement now? Okay? So go ahead, finish those measurements. And log in everything here. Okay. Don't forget, keep on taking pictures, right?
I have a question. The max, like less than 2 hours, like more than 1 kg, what is that number of more than the max? So do you want it in number format or because it was originally set to like 9.9?
Yeah, let's see. I didn't put the resolution of the scale. Let me show you the resolution of the scale. Here you go. Okay, here you go. For the scale, right? For the scale
Yeah.
is what? Is grams, right? It goes to a tenth of a gram. Okay? It goes to a tenth of a gram. If you convert to kilograms, what do you get? You get 0.0xxx. You should have 4 decimal places. Okay? You should have 4 decimal places for the scale. If you take a look here, let's see. Yeah, see that? Four, 4.1.
Oh, you have to write it down. How many millimeters?
Has to do with the instrument.
Oh no, no, we're right. We're good. Yeah, we're good. Yeah. Wait, this is for calibration.
Compare the diameter of the ruler with the diameter for a cubic sphere, right?
Yeah.
Right, with the ruler, with the caliper and the micrometer.
We're good. Calibration
Yeah.
scale.
Oh, okay.
We're fine also. We're doing Yeah, we're good. We're all good. We're good.
I'll be back, okay?
It's just in between the pipe and the floor. Yeah, it's right inside there. When you tighten it. It's a little hard, but yeah. You guys have 6 balls? No, we have 5. Yeah. 19 so like what, like 5? Oh, adding on, right? Because we need to subtract 19 first. Yeah. Alright, with the fourth, with this one. I think it was 5. I see. That's why I
You guys still have our base?
Wait, so
You guys are done?
alright, so they give us 5 minutes. So
There's only 5.
yeah, the first three. Yeah. They have smaller because just because we don't have they have smaller on
So when you give one key, you give one solid.
Why does it matter?
But that's I mean that's if he would if he would love to tweak this one. Next one. Oh, then yes, I think it needs to be have no. He didn't have no.
The reason the format of the map is it's because the scientific notation is less than computer information format. The combination of original values. Can you try to overlap on the weights? You said ranges between 3,000 average, and then
It's 18, 19, 20, right?
19, 20.
Okay, yeah. I see.
That's where the point you're looking
Yeah,
at.
it's just it looks it.
Yes.
Yeah, yeah. So it's 26 characters on the same number.
Okay, try using algorithm
Okay.
because we're working on like um, need to decide.
Oh, I think that might be the graph that I highlighted. Oh, I think that's the graph instead of
You need graphs.
yeah.
You need graphs. Where you need
Or kind of left. Yeah.
conditions like yeah.
I think
Yeah. That one was like more of a little bit. And when I measured it out, it was like the same thing as the production structural the centimeters right there. And then for the house, I was having the same issue. Mine there was 19. No, they're all like so
This was supposed to be I live down like just off of William Street. It was about like 15 miles. I still not that long. I didn't want to like take one street all the way down to the east right here, all the way down sit down and watch it. Say? Yeah. I think we're done measuring. I'm sure we're done measuring. Yeah, that's the problem. Oh, you want the chair just in case? Make sure you get it. I'm not sure if we're gonna need any more, I don't know. I don't want to take stuff away, so we're not.
There it is.
Where are they?
Oh, those are the spheres. Thank you.
Other lenses.
Yeah.
Next time, yeah, you gotta tell yourself. Slow, we'll let it slide.
Oh, and then so it's open
What's in there, right?
Yeah.
Only one? Two, actually. We're
You can have one anyway.
This one like that.
I don't know.
Yeah, and then we got there. Like it's like, I don't think we are. Measuring, we are. Measuring, yeah. I think we said our thought. I thought we were like 100% done. So we got this. Okay. Yeah, we're done measuring. So it's the set. I'm just saying, in general, like, even if I were to, I don't. I do a key one. That's not like much. Yeah. Well, we're talking about warehouse. Yeah. So pretty much we put the threads in a box and then ship them out. Yeah. They were like the hamburger buns. Hamburgers, the hot dogs, the dried rolls. And we should email each other some. Yeah. So I mean, we already have our rolls. You're gonna fix it. You're gonna pack it. Yeah, pack it. The shipment that you pick up from the store. Am I great? That's the part. Yeah, that's the part. Yeah, so. Yes, sir. What time? You want the graphs? We don't have the laptop part. Huh? We don't have the laptop part. You don't have not the laptop part. Okay, but I'm gonna tell you that once we get home. Okay. What we're gonna do, next time I'm gonna tell you other students to do. There's no lab report due yet. Okay. We will meet again next week. I'll tell you. But can you tell you what we have to do next when you go home? Oh, is that the same day? Yeah, that's what I'm saying, but it's gonna be.
Remember where your set was? Or is it just
Yeah, we just put them in there. They're in the sphere right here.
Oh, okay. Oh, then I
Yeah.
Okay, so what you have to do. Okay, once you finish collecting everything, you get everything? All the data? Okay, you need this data here, right? And you need this data here. What you're going to do next, you're going to plot the mass against the volume for the ruler. Okay, diameter, right? You're going to calculate the volume. One graph. Next graph, mass and volume for the caliper. Okay, and then mass and the volume for the micrometer.
All in one graph.
No, 3 separate graphs. Okay? 3 separate graphs. Okay, so here you go. Plot 3 graphs mass in the y-axis, remember it's the volume, not the diameter, volume of the ruler, volume the ruler in the x-axis, volume of the vernier caliper, mass, volume of the micrometer in the x-axis. Okay, so that's, and don't forget to get the density, right, of the steel, and then the others. You know, I will fill you in what you're gonna do here, and here. Okay. And by the way, when you plot the graphs, for all the graphs, you must have the how do you call it, the regression equation, right? Trend line and the R square value for all graphs. You already know how to do that, right? I did that in the first lab meeting. Show to you how to plot them. So I need your data in pen so I can sign you off. Okay? Write down your data, original data in pen. I'll sign you off. And we can all leave. Everything in pen? Okay. Bring it here. And don't forget to, wait a minute. Everybody's done, right? Okay, group number one. Okay, are you ready?
We need one more.
One more? Okay, so group number two. Okay, are you ready? Okay, bring your stuff here, please. Let's go. And where's the micrometer? You already turned it in?
We turned that in. We
And
turned in
what
our
about the
caliper,
spheres?
ruler, and the spheres are in here.
They're all there?
Yeah, we got everything.
Is that in pen? Gotta be in pen, not.
Has it be in pen?
Yeah, gotta
Oh,
be in
okay.
pen. Okay. You're group number two, right? 1, 2, 1, 2, 3, 4, 5. Group number three. Are you ready? Not yet? Okay. Group number four. Everything in pen? Gotta be in pen, okay?
Oh, it should be in
Yeah,
pen.
yeah, got a pen. Yeah, not pencil, okay? Did you turn in your equipment
put
already?
everything back here.
Everything here?
Yeah.
Okay. Scale. Your group number? 4. Okay. Group number 5. Not yet? Okay. Group number 6. Okay, is that the spheres?
Yes.
Okay, your group number 1, right?
Yes, sir.
You have 6? Yeah, we have 6. Please, 6. Your group number 6. How many you have?
Just 3.
3. Okay. Is that everything in pen?
It's in pen.
Yeah, gotta be in pen, okay? So I can sign you off. You turn in the caliper and the ruler too? And group number 7.
Not yet.
Not yet? Okay. 3, 4, 6. 2, 7. Ok. 3, 4, 5. Ok. 6. 7. Okay, group 1 is done, right? Okay, I'm going to stop here the recording.